All right, with our second addition rule example, we will again explore the addition rule, which is this. Now, sometimes we like to use this union symbol as our word for or as our symbol for the word or. And sometimes we like to use this, what we call intersection symbol, for our word and, right? So that's intersection. I guess I should have wrote that. Okay, so intersection symbol, but they mean the same thing. So remember, addition rule is A plus B minus wherever they overlap or happen at the same time. All right, so let's check it. Here we are. We have high school graduate, not high school graduate. We have homeowner, not homeowner. They give us a table. We're trying to find probability. Remember, probability is, in its essence, what I want divided by what I have available. Okay? So let's go. G here, so they're just defining the variable G as person is a high school graduate. H, a person is a homeowner. Okay? So let's do plain language number one, probability of G with that little C notation. Remember that C notation means complement, which means not. So I would say that this, in plain language, means the probability that a person is not a high school graduate, not a high school graduate. That is these people right here. They're not high school graduates, okay? So let's do the probability. Let's kind of do this real quickly. 119 plus 71 equals, that's 190 total non-high school graduates. And then it says, what is the probability that somebody is, again, not a high school graduate? So we're going to say probability of G complement is equal to 190 over, remember they told us at the beginning that there was 500 total. All right, let's work out this number. 190 divided by 500, basic probability, 0.38, which we could, if we want to, change to a percent of 38%. Leave it as decimal, change it to a percent, it doesn't matter. All right, so explain why probability of being a high school graduate or being a homeowner is not equal to just adding those two together, right? So that's what we're looking for here. Let me come back to this. I want to erase some stuff here because I want to come back up and use this chart. All right, here we go. I'm going to put some totals out here, you know, because this is, I want to put what we call the margins. Remember when we used to say margins? 221 plus 119. That's 340 total homeowners. 89 plus 71. That is 160 non-homeowners. 119 plus 71. That's 190 these people. 221 plus 89. And that's 310 of these people. Remember, it's giving me a total of 500. That's just going to help make it a little easier. All right, here we go. Why is it not equal to this? So check this out. Probability of G is person is a high school graduate. That is these people here. And probability of H is being a homeowner. That is these people here. All right, so check out what just happened there. I'm going to take these 310 people plus these 340 people and put that over 500. If you know the algebra there, 310 plus 340 is 650. 650 divided by 500. You can't have over 100% of the people you're talking about there. So something's definitely odd there. And what is odd in that calculation, if we did that, these 221 people, they were counted with the high school graduate group, but they were also counted with the homeowner group. You can't double count people. So this is where the general rule comes in. Probability of G or H is equal to the probability of G, which is 310 over 500, those people, plus the probability of H, that's going to be 340 over 500, minus the overlap. That is these people, right? And really, what is that? What is the actual addition rule trying to do? not let you double count those people, 221 over 500, right? We don't want to double count them. So here we go. We're going to go 310 plus 340 minus 221. And I'm going to get 429 over 500, right? Basic algebra rules. And I'm going to get 0.858. All right, let's move on here. Okay, so this is going to be a little flashback to what we did kind of the first day, talking about Venn diagrams and kind of how everything's orchestrated here a little bit. Or from the notes, not necessarily the first day. But Venn diagrams, we want to try to talk about this, right? So here we go. Here's a Venn diagram. I'm going to kind of put it in a box here. But we know we're dealing with two things. We got person is a high school graduate, right? That's G. And we got person is a homeowner, and that's H, right? So those are our two different, right? I'm coming back up here to the top. I'm looking at these two events. Now, the reason I made them cross, those cross, is because we have 221 people who are, in fact, both, part of both groups, right? So we put those 221 people in there, all right? So now, we just got to identify the rest. Now, in order to be a high school graduate, G, it should be 310 total. So what we need here is 89 to be here, because if I were to take all of high school graduates, the total is 310. So that makes sense, right? 310. And now, to be a homeowner, we need that to equal 340. So it's the 100, let me try this again. It's the 119 here. And why is that? Check it out. Because if you are a homeowner and high school graduate, then we need that to be the full 310, right? So that's what that looks like right there. All right, so then all you have, so check out all the numbers we've used so far. I'm going to come up here. We used the 89. We've used the 221. We used the 119. Well, guess what? We still got the 71. Where does the 71 belong on our Venn diagram? It belongs down here in the space outside of being a graduate or being a homeowner. So these are the people who are not high school graduates and not homeowners. Right there. That is a Venn diagram. That's how they look right there. It's a great visual way to do the same thing that the two-way table is doing, okay? All right, write the event is not a high school graduate, but is a homeowner in symbolic form, and then find its probability. All right, here we go. Is not a high school graduate. So I'm thinking high school graduate complement. But is a homeowner. So that would be and, or what we call union. So I would use this sign, or I would use the term and. It doesn't matter which one we want to use right now. So if you want to use the symbol or you want to use the words. And is a homeowner, okay, in symbolic form. That's really it right here. But now if they say find its probability, then I'm going to go like this. What's the probability that that happens? So let's go check it. Right? Not a high school graduate. That's these people here. And a homeowner. That's these people. This is the overlap. The 119 are both out of the 500. Right? 119 divided by 500. So we're going to go 0.238. All right? So there you go. So notice it didn't say like given that they're a high school graduate. No. They said that they are not a high school graduate and is a homeowner. That's the 119 people. Do you see them sitting in that spot out of the 500 people that are available to me? So basic probability comes into play there. All right, there you go.